In the previous class, we learned that the routers need to know the route for remote destinations. And that route can be fed into the routers. The routes can be fed into the routers manually. We call it as static routing. And the other option is dynamic routing protocol, which we will discuss later. Now, our focus today is static routing. We manually telling the router what direction the traffic to be forwarded for various destinations. For example, you have a router in the office connecting to two different, let's say, cloud. In this cloud, you have a network called 1.1.1.1, 2.2.2.2. Now this router, which is there in the edge, router edge, has got no direct connection with this 1111 and 2222. The router edge, RE, has got no direct connection. It is connected to the provider edge. These two are provider edge routers. The one in the green and the one in this purple. These two are provider edge. But that 1.1.1.1 is behind the provider edge. Edge router RE is not provider. RE is our edge router. We usually call it as customer edge. This customer edge router needs route in order to talk to this network and this network. It needs route. Now let's say the IP address of this interface is 20.0.0.1 and the IP address of this interface is 40.0.0.1 and the IP address on this side is 20.0.0.2. On this side is 40.0.0.2. The interface name is, let's say, Ethernet 1 and Ethernet 2. So Ethernet 2 IP address is what? 40.0.0.2. Now on router edge, what I need to do is I need to tell that if you wish to forward any packet, if you are receiving any packet to the destination 1, if the first octet is 1, I'm saying don't focus on the other 3 octets, focus only on the first octet. That's what we call it as masking. So I say if the first octet of the packet's destination, see a packet is coming and the packet's source address is, let's say, 10.0.0.1 and it wants to go to the destination 1.1.1.1. So we are telling router E, RE, when you receive a packet, if the destination address has got 1 in the first octet, if the first octet is 1, you need to send it to 20.0.0.1. Listen. This is what we call it as static route. You just send it to this router. This router will take care. You see, this may be connected to 100th router, doesn't matter for you. This 1.1.1.1 may be 100th router, doesn't matter. All that you need to do is send it to your next router. That is all you need to do. And it is the job of this router's administrator to move the packet to the other ends. Service provider will do that. So static route, you cannot write to this 100th router. No. You can only write to immediate router, next router. The command goes like this: IP route. IP route means route all the IP packet that wants to go to one network to this guy. It will deliver the packet here. And we need to write another static route, right? IP route. If you want to forward the packet to two network, 255.0.0.0, it should be sent to where? 40.0.0.1. Writing route like this to make router know what direction the packet to be forwarded. See, if it is one network, this is the direction. If it is two network, this is the direction. To make your router know this direction to the destinations, we write route like this manually. We call this as static route. Do you have any question?
No, sir.
Okay. Now there is a challenge. What is it? If the next router's address is not known to me, if the service provider, the 20.0.0.1, if I don't know, 40.0.0.1, if I do not know, how is that possible to send the packet to the next router? If I do not know the IP address of the next router, I can simply say my exit interface name. That is it. That is it. If you do not know the next router's IP, you simply say the exit interface. The packet will go out on that interface. On that interface, it knows the gateway. It knows the MAC address of the another. It knows the MAC address of the service provider side, so it can put the MAC address and send the packet. Simple. So if you are not aware of the next router's IP, you can give your exit interface address. Don't give your own exit interface IP. No. If you're giving IP, it should be next router IP. If you're giving interface name, don't give the next router's interface name. Give your own interface name. If it is name of the interface, it should be your own interface name. If it is IP address that you want to give, then give the next router's address. That is the gateway. Next router's IP address. You can also give both interface and IP address. That's up to you. But any one is enough. But if you want to give both, you can give both. Do you understand?
Yes, sir.
Okay. Now I'm going to do this lab and show you. We got one customer edge and we got two service providers to this customer, and I have connected the cables. Now the IP address in between the CE and PE1 is 20,000/8, which means here this side it is dot 1, this side it is dot 2. I hope you understand what it means. 20,002 here, 20,001 here. Likewise on this dot 1, let me write it clearly here, 30,001/8, 30,002/8. Now, as we are learning the static routing, I also want to introduce something called loop back interface. Listen carefully. I just want to have a network here. Instead of having a real network, I can create a virtual like this. Loop back 0. I'll give 1.1.1.1/32. Loop back 0. 2.2.2.2. Try understanding what I'm saying. You can connect a computer, put that in 2 dot network, connect one computer here, put that in one network to simulate. But I do not want to do that. I want a virtual interface which can respond to my ping like a physical interface. That's what called as loopback interface. Loopback interface is not a port which you can plug in a wire like you used to plug in on gig Ethernet. It's not having any port, but this interface can be assigned an IP address and you can ping and that will respond like a physical interface. Do you understand what is loopback interface?
Yes, sir.
Okay.
Sir, I don't understand. Sorry.
See, loopback interface is not a physical interface. But when you ping a physical interface, you get response. When you ping a loopback interface IP address, you will get a response. I want to repeat again. Loopback interface we create whenever we want an interface with IP address. But that interface that we want is not for connecting any computer or something. It is for just to put an IP address so that you can ping and verify. I repeat.
Okay, so there is no practical use of, the practical use is only for testing.
Yeah, very good. That's one
like pinging.
That's the best way that you have. That's right. You're right. But I want to again make it more clear. You're right, actually. You see, this gig Ethernet, I assign IP address. Why I'm assigning? So that I can connect another router and I can ping from here to this router. Now, why am I having a loopback interface on this router? Because I want another network. Because in our scenario, in our discussion, we want a loopback. We want 1.1.1.1 on the provider side. That 1.1.1.1 network, I want behind PE1. If you want a network behind PE1, you can have a physical network there, but you can also have a virtual network because it is behind PE1. You don't need a physical one for testing. I want a network there just for testing. Behind PE1 and behind PE2, I want a network so that I can test my static route. That's my aim. This is not a real network. I just want one 2.2.2.2 network and 1.1.1.1 network behind PE1. So instead of having your own physical switches and PCs and putting an IP address and then pinging, you can just create one loopback interface. See, this is the answer for this level of your CCNA networking knowledge. But the loopback interface have got various other use case.
Okay. Which we will learn later on.
Yeah,
But as of
definitely it is
now,
coming later on.
it is. Let's consider that it is used for testing purpose.
Correct.
Okay.
That is also a widely seen use case, testing purpose. Using loopback interface for testing purpose is the widely seen use case for loopback. But on top of this, there are also many other use cases, like whenever you have redundant path, using loopback and forming neighbor is best. Those are all big stuff. When we talk about routing protocols, we'll talk about those things. In this scenario, why are we creating loopback interface? I want to have a network behind provider edge routers. Two options. I can physically connect one device and have it, or I can create a loopback interface. Same like a physical interface responding to me when I ping, the loopback interface can also respond. So instead of going with a physical port and physical wire and physical device behind P, I'm going with loopback. Is that clear?
Yes, sir.
Okay. Now I'm going to start configuring from PE1. PE1 has got two networks. One is the loopback interface 1.1.1.1/32. The other one is gig ethernet 000, which is 20.0.0.2/8. So I like to name it as PE1 interface loopback 0. See, it got created because you create this interface. You don't need to again say no shutdown because you only created it. See, the physical interfaces are by default in a shutdown state. The physical interfaces are by default in a shutdown state for security. So we say no shutdown. To bring the physical interface up, we always say no shutdown. Am I right? Do you remember that?
Yes, sir.
But the loopback interfaces, you only created now. So you no need to say no shutdown. See, it has already come up. Why you need to say no shutdown? No need. And put the IP address 1.1.1.1, 255.255.255 to listen. Because it's a loopback interface. Because it's not a physical port. Because this interface is not a physical interface. You no need many addresses. Just one addresses is what you need. You cannot connect a computer there and have more addresses in the same network. That's why I'm masking it completely. All the loopback interfaces will be masked to /32. Okay? Any question?
No, sir.
Okay. Interface gig Ethernet, you have to bring it up by typing no shutdown because it's a physical interface. Shutdown for security reason. I am bringing it up by saying no shutdown. See, it has come up. Now, put the IP address, which is 20.0.0.255.0.0.0. Done. Now, I would like to go to PE2 to configure. PE2 route. PE2 host name PE2, interface loopback 0, IP space address 2.2.2.2, 255.255.255, interface gig 000, IP address is 30.0.0.2, 255.0.0.0, and I say no shutdown. See, I have said no shutdown. I can see the interface is coming up, but it is not fully up. You know why? The other end of the wire is still not configured. So there is no protocol possible to run on this port. Protocols cannot run. So when you check now, what is the command to check the interface status? Come to the privilege mode and type show IP interface brief. When you type this, you can see, though I have said no shutdown, when I say no shutdown, it comes up. Before no shutdown, it was administratively down like this. When I say no shutdown, it comes up, status comes up, no doubt, but the protocols on the line, on the wire, the protocols are down because the other end is not up. See, you have a pipe, okay? One side of the pipe is closed. Will the water flow? No. Which means the pipe is not functional. If the pipe need to flow water, both the ends should be open. Only then will pipe will carry water. Right now the interface is up administratively, but operationally it is down because the protocols couldn't run. The other end is shut down. On the CE side, the interface is down. But when you go to CE side and bring the interfaces up, see, let me give host name CE. Now when I say no shutdown, as soon as I say no shutdown, you will see two up. One is administratively up, another one is line protocol is also up. Now you go back to the provider edge, see it is green now. Because this line protocol has come up because the other end is up. You see? Show IP interface brief, which we typed some time back. Show IP interface brief. Now if you check, even this is up. Likewise, let me go to G001 and say no shutdown. Okay, we'll finish giving IP address, then we'll go to G001. What is the IP address on this port? G000 is 20001. Done. And then interface G001 IP address is what? 30001. Okay, so we have show IP interface brief. We have these two interfaces with this two IP address, and the interfaces are up. Likewise here, the first interface, physical interface is up, and then the virtual interface, the logical interface, loopback is also up. Now let us check the routing table. Listen carefully. Show IP route. This is what you have in the routing table. It knows about 30. How it knows about 30? Because I gave this IP address here on G000, it automatically, dynamically learned this. And when I give IP address on the loopback, it dynamically learned this. Okay. Likewise, if you go to router 1, P1, show IP route, this also knows only about 20 and 1. Okay. Now let us go to CE. Show IP route. See, this router do not know about 1 network and 2 network. 1.1.1.1. If I ping, will I be able to ping? Answer someone. If the route is not there in the routing table, see, there is no route for this destination. The ping will not happen because the router do not know. This dot no, it means failed. See, success rate is 0%. Again, I'm going to ping 2.2.2.2. This also will fail because there is no route in the routing table. So what is the solution? What are we going to do? We are going to write
Static route.
Static route, like I have written here. Now, let us assume in the first scenario, let's assume you know the IP address of the next router. Not assuming, we know it. We know the IP address of the next router. So if you have a question, what is that?
So when you give to the P router and P3 router, P1 and P2, you give two commands. One is the interface IP address and the normal IP address. But in the configuration shows as loopback IP address. That is the question.
Wait, let me try understanding your question. See, on PE router, I gave IP address to loopback 0, which is 2222. I gave IP address to gig ethernet, which is 30.0.0.2. So 30 network is on gig ethernet 00. Loopback is on, 2 network is on loopback. Now what is your question, please?
You did not mention loopback. You just typed IP
No,
address
you did not notice.
2.2.2.32.
No. I'll show you.
Uh,
I'll show you. Look at this. What is this?
okay.
When I say
Okay.
interface
That
loopback, it automatically created interface loopback. And then see,
okay, I just saw these three lines.
Okay, see, I'm inside. If means what? I'm inside the interface. Which interface? Loopback interface. And I gave address. Okay. You can also see the same when you type show IP interface brief. You see, 2222 is on which interface? Loopback. Okay.
And you just give because you wanted to test the ping to 2.2.2 ping. Okay.
Yeah. You see, I'm trying to welcome. I'm trying to ping. The ping is not happening. The reason is there is no route to reach 2222 and 11111. Now, shall we write a static route now? Are you ready?
Yes, sir.
Okay. This is the command. All the IP packet should be routed if the destination is one network to the next hop. See, 1.1.1.1, if I want to ping, I need to go to this guy, PE1. So I should not give 30.0.0.2. I should give what? 20.0.0.2. That is the gateway. Now let's check the routing table. Show IP route. You see, I have statically written, S means static, okay? Let me show you that also. S means static. C means connected. L means locally configured on the link. This is the address we have put in the link. Connected 20 network. So statically, I have written a route saying any packet that wants to go to one network need to be sent to the next hop whose address is 20.0.0.2. Now if I ping the one which I was pinging earlier, this ping was not happening earlier, but now it will ping. See, the first packet is lost because it's the first time when you ping, the first packet will be lost. But now if I ping again, all 100%. This ping is happening, it is because of this route. When I ping 2222, it is not pinging because still we have not written a route for this destination. So I'm going to write now route to this destination 22222. IP route to network. If this is the mask, send the packet to where? Someone tell me, where should the packet be sent if I want to go to 2222?
30.0.
Exactly.
P1 is done, P2 in
30.0.0.2.
2.
Let us verify that in the routing table now. Show IP route. I can see another route, static, another static route, but this time it is for 2 network, and this is the gateway. Now let us try pinging 22222. That also will be pinging. First packet will be always lost, as I said. I'm able to ping because the routing table has got route. So one thing you might have learned now, that for the connected network you no need to write route. The moment you put the IP address, the route will appear. But for those networks which are remote, connected behind the next router, for those networks we need to show the route. We need to show the direction. We need to show to which next hop the packet need to be forwarded. Doing that manually is what called a static route. Now, what if this addresses of the next router is unknown? Assume I do not know these addresses. Then how will we write? Listen, I want to now remove these static routes which I have written. How to remove something which you have configured? First of all, you need to type exactly what you have configured and then go to the beginning of the line and put no and hit enter. Simple. Put no in front of what you configured and hit enter. It will get erased. I'm also going to remove another static route which is 1. Now to go to the beginning, you press Ctrl A. It goes to the beginning. See, the cursor is now blinking at the beginning. And now type no, enter. Let's verify the routing table now. Show IP route. See, there is no route. If I ping now, will the ping go? No, because there is no route. I removed the route. I want to use the exit interface because I do not know the next hop. So how do we write that? Very simple. Same command, IP route. If you wish to go to one network, what is the exit interface in this picture here? It is G000, okay? G001 is the below link. This may look a little bit confusing. Let me, you see now? G00 is the above link that goes to 1111. Okay, so send the packet out via G000. It is okay. Point-to-point link only we have, directly connected to another. Now, IP route, similarly, if the packet needs to go to this network, what is the interface? Gig 1. Am I right? Say something.
Yeah, it's the
Yes, sir.
interface.
Yeah, G001 only will take you there. Yeah. Okay. So I hit enter. Now let us go and check the routing table. Show IP route. Look at this. This is also a static route, but pointing towards the directly connected interface. Send the packet out on G00 if it needs to go to one network. Send the packet on G001 if it needs to go to two networks. So now also I'll be able to ping. See, I can also ping 1111. I'm able to ping 11111 and 22222. Are you comfortable with what I'm showing? Is there any question?
Yes, sir. So can you explain the routing table for the C and L, the connected
Okay, C means the IP address that you have assigned on the connected wire. It may be loopback, it may be Google, gigabit, giga Ethernet. That doesn't matter. If you have configured an IP address on the port of the router, I have configured an IP address on this port G000, this address, and and router is to connect networks. See, this is the IP. This is the exact IP over the link. Over the link, I gave this IP, but it's locally configured IP. L means local. Now, what is the network of this IP? 20. So connected network. If you see network, it is 20.0.0.0/8. If you see IP on that port G000, locally configured is 20.0.0.1. See, this is locally. Do not get confused with the local. It should not confuse you. In older versions, we never had this L and all. Only the newer versions we have this L. That is to say what address exactly on the port. Okay. You need to focus only on the network. Connected, static. Ignore that L always. L is nothing but the IP address on the port locally configured. C means connected. Okay, what is the next question?
No, that's all, sir.
All right. So you have to do this lab daily. Whenever I do some lab, you have to do lab. So I say now this PE1 router, PE1, listen carefully. This PE1 show IP route. This don't have route to reach 22222. Am I right? This don't have route to reach 22222. Not only that, this don't have a route to reach 30 network, 30.0.0.0. Okay.
Yes, sir.
Likewise, this PE2, if you notice, this also do not have route to reach 20.0.0.0 network and 1.1.1.1 network. See, what you can do is, because these two are edge router, you can tell that IP route any network. This means what? Any destination you do not know. It can be any subnet mask, doesn't matter. You just send it to 30.0.0.1. You see, this PE2 router, this is the only direction where you have some networks. So instead of saying for 20 network, go to 30.0.0.1, for 1 dot network, go to 30.0.0, instead of saying for every single network, instead of saying the same gateway, you can say any destination that you do not know, you just send it to C. C's address is this. This is what we called as default route. Now let's check the routing table. Show IP route. Look at this. S star. Star means what, you know? Default. Candidate. Default. What does that mean?
So, sir, any
Any means
so,
what, you
sir,
know?
anything
If I say ping 22222, it will match here. Sorry, 2 is connected. If I say 1.1.1.1, there is no route for 1111, but this says anything. Means, you know, for 1, it will send the packet to this guy. See, the packet will come to this guy. And this guy knows 1111. We just wrote the route, right? This guy knows where is 1111. This router will forward the packet here. Now, similarly, I'm going to write a default route on PE1. IP route any destination that you do not know, any subnet mask that may be, just send the packet to 20001. That's it. You see, you will understand after I finish this. What are the networks that this router do not know? Answer.
30 and also
Now you see, I'm going to ping 30.002. What are the other networks that it do not know? 22222. Correct?
22.
See, for both, I'm able to reach with one any. You understand that any now?
Yes, sir.
Saif? You understand the meaning of any?
Any source or anything.
Any destination, not any source, any destination. Now, let us also go to PE2 and try pinging. Sorry. PE2. Now, this guy I do not know about 1111, but when I ping 1111, I'm able to ping. If I want to ping 20, this guy do not know about 20. That also I can ping. So where do we write this default route? This default route we will write only on the stub router. What is a stub router? What is a stub router? The router that has got all the unknown destinations in one direction. Listen to my words. This router do not know about 30 and 2. To reach 30 and 2, this is the only direction. If you have only one direction to go to all the unknown destination, we call it a stub router. So you write this default route only on the stub router. See, this is also a stub router because for PE2, unknown networks are 20 and 1. And this is the only direction. Now, this is not a stub router. Why? This destination is in this direction. This destination is in another direction. So you should not write default route on the non-stub router. Did you understand where to write default route? Only on the stub router, meaning only on the router where you have one gateway to reach all unknown destination. Is that clear?
Yes, sir.
Now, listen through to this video once or twice till you get it fully and do this lab before you come.